Hello. In this video, I want to find all relative extrema for the following function, as well as where the function is increasing and decreasing. So to figure this out, we want to go ahead and understand that what we really want to do is we first want to find critical numbers, and then use the first derivative test. So to find critical numbers, we want to find where the derivative is equal to 0 or undefined. Because it's a polynomial function, we just need to find where the derivative is equal to 0. So let's find the derivative. Bring the 3 down, making that 6x squared. Bring the 2 down, making that negative 6x. And then minus 72. And notice that the 15 just becomes 0, so it's gone. And then we set this equal to 0 and solve. So 6x squared minus 6x minus 72 equals 0. My recommendation is go ahead and divide by 6, and that's going to give us x squared minus 6x minus 72 is equal to, the minus x minus 12 is equal to 0. There we go. Notice I divided everything by 6. And then I factor. 2 sets of parentheses equaling 0. We have an x and an x with a plus 3 and a minus 4. Good. Set each one equal to 0 and solve. So x equals negative 3 and x equals 4. And what we're going to do next is we're going to go ahead and find whether each of these is a relative maximum or a minimum. These are both critical points. We know that for sure. Question is, are they relative extrema? So, we need a number to the left of negative 3, a number between negative 3 and 4, and a number to the right of 4. So I'm going to go ahead and choose, say, negative 4, 0, and 5. Those are the x values. Then we're going to take that and plug it into f prime and to determine is this positive or negative. Now plugging in negative 4, over here, negative 4 squared times 6 minus 4 times, minus 6 times 4, and then minus 72. When you type that in, what does that give you? Well, 4 squared is 16. 16 times 6 is 96. So we have 96, and then negative 6 times negative 4 is positive 24. So 96 plus 24 is 120. 120 minus 72, that's positive. So it is positive in this region, which means it's going up from left to right there. Now let's plug in 0. Plug in 0, 0, both of those are 0. We're left with the negative 72, so it is negative in this region. In other words, this function is going down from left to right. Then you take the 5 and plug it in. So 5 squared is 25. 25 times 6, well, 25 times 6 is what? 125? No, 150. Yes, 150. Negative 6 times 5 is negative 30, so that means the 120. 120 minus 72 is, again, positive, making that go up from left to right. So there you go. So the derivative in these regions are positive, negative, and positive. In other words, it's going up, down, and up. So at negative 3, question is does it change signs between each side? This is positive, and then it becomes negative. So it is, yes, it is a relative extremum. And this 4, it's going down and then up, and it does change sign between those two regions. So yes, that is also a relative extremum. So let's go ahead and write down where this function is increasing and decreasing. It is increasing in the interval negative infinity to negative 3, and then my lab math will want a comma, so comma 4 to infinity. And it is decreasing in the interval from negative 3 to 4. Good. Now let's talk about the relative extrema. There will be a relative maximum at x equals negative 3. Now the actual relative maximum is whatever you get when you plug it in to the original function. So my recommendation is take your calculator out and type that in. And that's what I'm doing right now. I'm taking the calculator out. I'm going to go to y equals, just type this in as 2x cubed minus 3x squared minus 72x plus 15. And then I'm going to go to the table. At x equals -3, that tells me 150. So there's a relative maximum of (150) at x equals -3. So the relative maximum point would be the coordinate -3, 150. Now, there's also relative minimum, and that occurs at 4. And so that's at -193. So a relative minimum of -193 at x equals 4. And there you go. Now again, that would be the coordinate 4, -193. Excellent. Alrighty. Well, I believe that's it for this video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.